Good morning, one and all. Please tell me whether my screen is visible or not. Is it visible?
Yes, sir, it's visible, sir.
Okay, thank you. Yeah, today's topic we are going to see is thermistors. That means the temperature measuring instruments we are going to see. From now onwards, we will see the thermistors, thermocouple, like that. Actually, I will I will show there are different types of temperature. I will stop the sharing. Actually, there are different types of temperature sensing devices are there. I will show that one firstly. Is it visible? Is it visible? Vamsi? Okay. This is the measurement of temperature. The temperature is a thermal state of a body which distinguishes a hot body from a cold body. It is going to distinguish the hot body temperature as well as cold body temperature. The temperature is going to distinguish like that. The temperature of a body is proportional to the stored molecular energy. Temperature of a body is proportional to the stored molecular energy. It is some sort of energy it is going to store. It is going to store molecular energy. That is average molecular kinetic energy of the molecules in a system. It acts as a kinetic energy of the molecules in a system. Okay. Temperature of a body is proportional to the stored molecular energy, that is the average molecular kinetic energy of the molecules in a system. Temperature, this temperature may also be defined as the measure of the mean kinetic energy of the molecules of a substance. The degree of hotness and coldness of a body or environment measured in a definite scale. The degree of hotness and coldness of a body or an environment measured on a definite scale. The driving force, the driving force or potential causing the flow of energy as heat. Flow of energy as heat is known as temperature. The degree of hotness or coldness of a body or environment measured on a definite scale, the driving force or potential causing the flow of energy as heat. That flow of energy is going to be takes place in the form of heat. Here, gas will not occupy gas will not occupy any volume at a particular temperature. This temperature is known as absolute zero temperature. That absolute zero temperature is given by 273.15 degrees centigrade. Absolute temperature is equal to thermometer reading, that is given by plus 273.17 degree centigrade. Actually, this is Fahrenheit. Plus this is the sorry, this is the thermometer reading degree centigrade plus 273. We are going to take it as like this absolute temperature. Here there is the expansion of thermometers are there. This is the first basic temperature sensing device, that is the liquid in glass thermometer. Liquid in glass thermometer, this is the basic one. Inside this bulb there is a mercury will be present. Due to the expansion of this basic principle is expansion of the liquids will takes place due to the heat, and due to that expansion of the liquid, mercury will be flow along this capillary tube. Upon this tube, by using this mercury bulb, along this capillary tube, that mercury is going to flow. This is the scale, and inside this thermometer, nitrogen glass is going to be filled. This is the basic one, and this is the bimetallic strip. Bimetallic strip thermometers are also present. One end is going to be fixed, and another end, two dissimilar metals are going to be given here, and there is a movement in the bimetallic strip which is going to be takes place. This is another type of thermometer, And this is the helical type. Helical type. This is the this is the bulb, and this is the bimetallic helical strip. Helical strip, and other end is connected to the pointer. Upon the pointer and scale, we can measure the temperature. This is the spiral type of bimetallic strip. This is the spiral type of bimetallic strip. Another end is connected to the pointer, and we can measure the temperature. This is another type of thermometer. Okay, and that that can be measured in terms of it is going to be measured with respect to time as well as temperature. This is the gas, vapor, liquid, bulb without well, bulb with well. Like that, we can plot different types of characteristics. Next one is pressure thermometers are filled systems also. This is the inside this one vapor is going to be filled, and we can measure the temperature. Vapor, bulb as well as liquid is going to be given, and this is the capillary tube, and board-on tube is connected to the other end of the tube, and we can measure the temperature. Liquid filled thermometers. This is just similar to the previous one. Bulb, liquid, and capillary volume pressure measurement is going to be takes place. This is another type one, another type of thermometer. And this is the electric. These are the electrical type of thermometers. Here RTD. In the previous class, we have seen this RTD, resistance thermometer. We have earlier seen this one. This is the Wheatstone bridge, and this is the RTD. In this way, RTD can be connected in the Wheatstone bridge position, and we can measure the what is the temperature. Now we are going to see thermistors. We are going to see this thermistors. Okay, next later on this later on this one, we will see the thermocouples also. There are different types of thermistors are there. Those are B type, disc type, washer type, wafer type, and rod type. Different shapes of thermistors are there. First one is bead type. This is glass. This is the glass, and inside this one, this is the thermistor bead. This is the disc type. This is the disc type of thermistor, and this is the washer type of thermistor. This is the washer. In This is the washer type of thermistors, and this is the wafer type of thermistors, and this is the rod type of thermistor. Shape depends upon the shape. These thermistors are given different names. Okay, this is the basic concept for temperature measurement. You will see the actual concept, that is thermistors and thermocouples. Here, thermistor, thermistor, thermally sensitive resistor. This is the full form, thermally sensitive resistor, or non-metallic resistors. These are not going to be metallic. This is just like a semiconductor material, or non-metallic resistor, that is semiconductor. It is going to be manufactured with semiconductor material made by sintering mixtures of metallic oxides such as manganese, nickel, cobalt, copper, uranium, like that. By using these materials, this thermistors is going to be manufactured. Thermistors have a negative temperature quotient. Semiconductors is also having negative temperature quotient. That is, resistance and temperature is inversely proportional to each other. If resistance increases, temperature is going to decreases. If resistance increases, temperature is going to rise, like that. These two parameters are inversely proportional. That is a negative temperature quotient. The figure shows a graph, that is resistance versus temperature of a thermistor. Later on, we will see this figure graph. The resistance at room temperature, that is 25 degrees centigrade, for commercial units ranging from, the resistance of this thermistor is given by normal one is 100 ohms to the 10 mega ohms, like that. The range of the resistance for the thermistor is 100 ohms to 10 mega ohms. There are These thermistors are suitable for use only up to 800 degrees centigrade. The maximum range is thermistor maximum range is 800 degrees centigrade. In some cases, the resistance of thermistors at room temperature may decrease by 5 degrees and 5% for each 1 degree rise in temperature. ఒక ఇప్పుడు సమ్ కేసెస్ కొన్ని కేసెస్లో ఏంటంటే రెసిస్టెన్స్ అనేది వేరీ అవ్వచ్చు అనమాట. ఆ వేరీ అయ్యేది ఎంత అవుతుంది? 5 డిగ్రీ 5% వేరీ అవ్వచ్చు అనమాట. ఫర్ ఈచ్ 1 డిగ్రీ రైజ్ ఇన్ టెంపరేచర్, ఒక్కొక్క డిగ్రీ రైజ్ ఇన్ టెంపరేచర్లో 5% వేరియేషన్ అనేది రెసిస్టెన్స్లో ఉంటుందని చెప్పి చెప్తున్నారు అనమాట. అదే, దీస్ ఆర్ ది పాయింట్స్, బేసిక్ పాయింట్స్ రిగార్డింగ్ థర్మిస్టర్. వీ విల్ గో ఇన్ డెప్త్ కాన్సెప్ట్ ఆఫ్ థర్మిస్టర్. This is thermistor, thermal sensitive resistors. These are different types of thermistor, that is bead type, disc type, washer type, wafer type, and rod type. Thermistors are non-metallic resistors, semiconductors of ceramic material having negative temperature coefficient. When the thermistor is subjected to a temperature change, the resistance of the thermistor changes. This change in resistance of the thermistor becomes measure of change in temperature. When calibrated, the resistance of the thermistor decreases with the increase in temperature and vice versa. Here, negative temperature coefficient means if we increase the temperature, resistance decreases, and resistance increases, temperature decreases, like that. The main here, this is the basic equation. Basic equation for this thermistor. Please memorize this one. This is the resistance of thermistor at T1 degrees is given by RT1 is equal to RT2. This is the T2 degrees, and this is the Kelvin. In terms of Kelvin, it is given here. For that sake, I am giving degree Kelvin. RT2, that is temperature T2 degree Kelvin, that is exponential of beta. Exponential of beta is constant here. Depends on this beta value depends upon the material, depends upon the material we are using, and this beta value ranges from 3500 degrees centigrade to 4500 degrees centigrade. And this beta into 1 by T1, this is the T1 temperature, minus 1 by T2. This is the relationship between the RT1 and RT2. Also we can simply call it as this. RT1 is equal to RT2 exponential of beta into 1 by T1 minus 1 by T2. This is the basic relationship for thermistors. The main part of a thermistors are construction part of this thermistor. The a metallic tube which houses a thermistor sensing element. This is the thermistor sensing element, disc type thermistor sensing element we are using here. The installation separates the thermistor sensing element from the metallic tube. From this one, this is the insulator. This is the insulator. Insulation separates the thermistor sensing element from the metallic tube. ఈ మెటాలిక్ ట్యూబ్ నుంచి ఇక్కడ నుంచి ఈ మెటాలిక్ ట్యూబ్ నుంచి ఈ ఇన్సులేటర్, this insulator, it is going to be protected. Lead wires are drawn and from the thermistor sensing element. Lead wires, these two are the lead wires are drawn from the thermistor sensing element. ఈ thermistor sensing element ni lead wires, we are going to draw these lead wires. The metal tube, the metal tube sensing element and leads together forms a thermistor used to measure temperature. We are going to use this metal tube sensing element and leads together forms a thermistor. uh, Forms a thermistor here, and we are going to use this thermistor for measurement of temperature. The leads of thermistor is connected to the Wheatstone bridge here. These leads are connected to the Wheatstone bridge. The same principle we are going to use here. These two are A and B are two arms, and C and this is the thermistor resistance. Let it be that resistance part. Let it be D, like that, and these two arms are comes under. This is the this is the part. This is the part is used for make this galvanometer null position, like that. Okay. A known constant current is passed to the thermistor sensing element, and the initial resistance of the thermistor sensing element is measured using the Wheatstone bridge. ఒక కాన్స్టాంట్ కరెంట్ని పాస్ చేస్తాం అనమాట ఈ సర్క్యూట్ ఎంటైర్ సర్క్యూట్లో థర్మిస్టర్ సెన్సింగ్ ఎలిమెంట్. And the initial resistance, what is the initial resistance of the thermistor, we are going to measure using that Wheatstone bridge. Now the thermistor is introduced into the medium whose temperature is to be measured. Due to the change in temperature, assume the change in the positive direction, let it be, the sensing element of the thermistor gets heated, and due to this heat, the resistance of the sensing element also changes. This thermistor is get heated, the heat అవుతూ ఉంటుంది, temperature gets increases, and the resistance is also going to be decrease. Temperature increases here, and the resistance of that thermistor is going to be decrease here. Now, the change in the resistance of the sensing element of the thermistor is measured using the Wheatstone bridge. What is that change is going to be measured by the Wheatstone bridge, and it is very small amount. Resistance is going to be very small amount. Why? Because the temperature is keeps on increases. This change in resistance becomes a measure of the temperature here. ఆ రెసిస్టెన్స్ ఎంతైతే చేంజ్ వస్తుందో దాన్ని బట్టి మనం స్కేలింగ్ ఫ్యాక్టర్ వేసుకొని ఎంత టెంపరేచర్ అనేది చెప్పాలన్నమాట. అది but calibrated, that this temperature is going to be calibrated in terms of resistance. In terms of resistance, this temperature is going to be calculated. ఈ ఈక్వేషన్ బట్టి ఇప్పుడు RT1 RT1 టెంపరేచర్ ఎంతని ఎట్లా చెప్తాం, ఈ టెంపరేచర్ T1 T2 నోన్ అనుకోండి, అప్పుడు RT2 వాల్యూ ఆల్సో నోన్ అయితే అప్పుడు I can get the what is the actual resistance of the thermistor. Okay. Materials, the metal oxides of copper, uranium, nickel, etc. These metallic oxides are mixed with binders, pressed with the required shapes, and then they are sintered in the different forms of bead type, wafer type, washer type, and disc type of thermistors like that. Okay. Applications of this thermistor is temperature compensation can be done, time delay circuits, measures thermal conductivity, measure pressure and flow of liquids. Precision temperature measurement is possible by using this thermistor, and it is that precision temperature range is 100 degrees to 300 degrees centigrade like that. Advantages of this thermistor is it is low cost, accuracy is high temperature range, that is 800 to 1100 degrees centigrade, ability to withstand mechanical and electrical stresses, small size, resistivity is high. And disadvantages of this thermistor is non-linear scale, resistance of thermistor increases when time lapses, aging effect may comes here, that is due to the aging effect, these parameters like temperature and resistance is going to be vary. The instrument is not going to be work due to that aging effect also. And self-heating effect is also may comes into the picture. Due to that self-heating effect also, our instrument is going to be damage may come across for the instrument. This is about thermistor. you need to draw you need to draw this diagram. This is the basic equation. construction part Construction part, operation part, applications part, advantage and disadvantage. And this graph, these are the graph. This is the temperature versus log resistance. By increasing the temperature, by increasing the temperature, this is the temperature, resistance is going to be decreases. This is for this 300 degrees centigrade, resistance is very small, between 10 and between 1 and 10 like that. This is the graph for the thermistor. This is the maximum safe continuous temperature. Up to 300 degrees centigrade, we can measure the accurate values for the thermistor. And this is the other theoretical part. Just to go through this one, rod thermistors are extruded through the dies to make long cylindrical units of 1.25, 2.75, and 4.75 mm in diameter, and 12.5 mm to 50 mm long, like that. Different types of cylindrical type of thermistor. Leads are attached to the ends of the rods. Their resistance usually varies from 1 to 50 kilo ohms like that. The advantage of the rod thermistors over other configurations is the ability to produce a high resistance units with moderately high power handling capability. Thermistors are connected in series or parallel combinations for applications required increase the power handling capacity also. Thermistors series లో కనెక్ట్ చేయొచ్చు, parallel గా అయినా combination లో కనెక్ట్ చేయొచ్చు అనమాట. Depends upon our requirement. This by connecting in series fashion or in the parallel fashion, power handling capability also gets increases. High resistance units find applications in measurements that employs a low lead wire or కేబుల్స్. లో లీడ్ వైర్స్ అంటే చిన్నగా ఉండే కేబుల్స్ యూస్ చేస్తారన్నమాట హై రెసిస్టెన్స్ యూనిట్స్ కావాలంటే. Thermistors are a non-linear device over a temperature range, although now units with better than zero point 0.2 linearity over 0 to 100 degrees centigrade temperature range are available. The total sensitivity of a thermistor is approximately 3 millivolts per degree centigrade at 200 degrees centigrade. This is typical sensitivity. Typical sensitivity of a thermistor is 3 millivolts per degree centigrade. 3 millivolts కి చేంజ్ ఓవర్ వస్తూ ఉంటుంది అన్నమాట per degree centigrade. This is the typical value for thermistor. Okay, this is about thermistors. We will see the next concept is thermocouples. Next concept is thermocouples. This is also very important temperature measuring instrument. Here, am I audible, students? Am I audible? Anyone, please respond. Okay. Hmm. One of the most commonly used methods of measurement of a moderately high temperature is ఇప్పుడు ఇప్పుడు మనకు థర్మిస్టర్ రేంజ్ ఎంత ఉందమ్మా, మ్యాక్సిమం ఒక 1100 degrees centigrade అనుకుంటున్నాం. ఒక డిస్క్ టైప్ ఆఫ్ డిస్క్ టైప్ ఆఫ్ థర్మిస్టర్కి ఒక రేంజ్ ఉంటుంది. అదే వేఫర్ టైప్ ఆఫ్ ఇంకో రేంజ్, అట్లా డిఫరెంట్ డిఫరెంట్ డిపెండ్స్ అపాన్ అవర్ రిక్వైర్మెంట్, డిపెండ్స్ అపాన్ ది మెటీరియల్ వీఆర్ యూజింగ్ ఫర్ ది థర్మిస్టర్. The maximum for the thermistor temperature measurement range is 1100 degrees centigrade like that అనుకుందాం. For example, in order to increase that temperature range, we are going for thermocouples. Thermocouple is a very commonly used in every industry. Thermistors are going to be used normally. RTD thermocouples and thermistors. Maximum in most of the companies, thermocouple is mostly used అనమాట. థర్మోకపుల్ ఎక్కువ యూస్ చేస్తాం అనమాట. Most of the commonly used methods of measurement of moderately high temperature is thermocouple. Thermocouple operation is based on Seebeck effect. Basic principle is Seebeck effect. Seebeck effect states that when two dissimilar metals are joined together, an EMF is generated. Simple statement is like that. A thermocouple therefore consists of a pair of dissimilar metal wires joined together at one end, sensing or hot junction, and terminated at the other end, that is a reference or cold junction. Two junctions లో ప్లేస్ చేస్తాం అనమాట థర్మోకమ్. Two dissimilar metals I am going to be used. One junction is at hot junction and another junction is at cold junction, which is maintained as known constant temperature referenced. It is maintained at known constant temperature. ఒక known constant temperature దగ్గర ఈ reference junction ని మెయింటైన్ చేస్తాం అనమాట. When a temperature difference exists between the sensing junction and the reference junction, ఈ సెన్సింగ్ జంక్షన్ అండ్ రెఫరెన్స్ జంక్షన్ ఒక the temperature difference exists between the sensing junction and the reference junction, and EMF is going to be produced. Like that, I am going to acquire some small change in the voltage in the form of EMF. I am going to it is going to produce some EMF here, which causes the current in this. Due to this EMF, I am going to which it is going to cause some flow of current in the circuit. It is just like a closed loop circuit. In that, some EMF, small amount of EMF is generated. Due to that EMF, I am going to I'm going to get some flow of current inside the circuit. When the reference and is terminated by a meter or a recording device, the meter indication will be proportional to the temperature difference between the hot junction and the reference junction. Okay, and this is the actual concept. We will see the what are different effects, thermoelectric effects. We will see thermocouple thermocouple thermometer. Here this is one metal, and this is another A metal, this is B metal. One junction is maintained at hot junction, let it be TH, and another junction is maintained at cold junction, okay, TC, like that. See, for higher range of temperature, that is about 650 degrees centigrade, field thermometers are unsuitable. Above 650 degrees centigrade మెజర్ చేయాలంటే చాలా వాటికి థర్మామీటర్స్ కూడా సూటబుల్ అవ్వు అనమాట. ఫర్ high range of temperatures, thermocouples and pyrometers are going to be used. We are going to used for a high range of temperatures, can be done by using these thermocouples as well as pyrometers. Pyrometers అంటే ఏంటంటే మనం డైరెక్ట్గా అక్కడ అంటే రిమోట్ ప్లేసెస్ టెంపరేచర్ని మెజర్ చేయడం కోసం పైరోమీటర్స్ యూజ్ చేస్తాం అన్నమాట. అంటే రేడియేటర్స్లో కానీ రేడియేటర్స్ అట్లా ఉంటాయి అన్నమాట. అంటే బాయిలర్స్లో టెంపరేచర్ మెజర్ చేయాలనుకోండి, బై యూజింగ్ దిస్ పైరోమీటర్స్ వీఆర్ గోయింగ్ టు మెజర్. అంటే డైరెక్ట్గా వెళ్ళి మనం మెజర్ చేయమన్నమాట. డిస్టెన్స్లో ఉండి దాన్ని ప్లేస్ చేస్తాం. అక్కడ ప్లేస్ చేసి డిపెండ్స్ అపాన్ దట్ ఎమిటెడ్ హీట్, that pyrometers is going to send the what is the temperature, what is the maximum amount of temperature, like that. Okay. చెప్పాలంటే వైర్లెస్ టెంపరేచర్ మెజర్మెంట్ అని చెప్పుకోవచ్చు పైరోమీటర్స్ది, సింపుల్గా చెప్పాలంటే. Thermoelectric effects, these are the some of the effects we should be familiar. ఇంటర్వ్యూస్లో ఇది అడగచ్చు, అందుకని చెప్తున్నాను ఈ ఎఫెక్ట్స్. వెన్ దట్ ఆల్రెడీ మనం ఇంటర్మీడియట్లో చూసినవే, ఒకసారి మెమరైజింగ్ చెప్తున్నాను అంతే. When the two junctions of a pair of dissimilar metals are maintained at different temperatures, EMF, that is electromagnetic force, is generated. The phenomena of generation of EMF is called Seebeck effect. This effect is known as Seebeck effect. This effect is reversible in nature. This effect may be reversible. Let it be change in, that is open circuit voltage, change in voltage, alpha AB delta T. That is this alpha can be Seebeck coefficient, that is alpha A minus alpha B. This is the change in temperature difference between material A and B. Material A and B. This is the equation. In this way, the change in the EMF as well as temperature with respect to the Seebeck constant. This is the equation. This is the equation for the simple equation for the Seebeck effect. Okay. Next one is Peltier effect. If direct current is passed through a pair of dissimilar metals, there is a heat of one junction. ఒక జంక్షన్ ఏమో హీట్ అవుతుంది అనమాట. కూలింగ్ at the other depends upon the material combination. At the junction between the two dissimilar metals, the heat is evolved or absorbed in unit time is proportional to the current here. It is going to be proportional to the current, and it is given by QP. QP is equal to pi ABI. Pi ABI. We are going to talk about current here. Peltier effect we are going to talk about direct current here, whereas the Seebeck effect we are going to talk about EMF. Okay, this is the heat evolved or observed. Phi AB, that is the constant term, Peltier constant. Phi A minus phi B. This is the direct. I means direct current in amperes. This is the reversal. This phenomena is also in the reversible in nature. This is about Peltier effect. In this way, flow of current will take place inside this two dissimilar metals. Next one is Thomson effect is also there, and Jolien effect is also there, and the conduction effect is also there. When a current passes through the single conductor having a temperature gradient, heat transfer is given by, this is the delta Q by dx, delta Q by delta x, like that. This is the change. Some change will be takes place here, and this is the Thomson heat transfer, tau I dt by dx. This is the temperature gradient with respect to the distance. Tau is Thomson constant. I is flow of current through the conductor. Let it be, this is the material. This is the material. This is the charge delta Q, and this is the temperature, the change in the temperature T plus delta T plus dt, and this is the, with respect to the distance, it is dx. This is known as Thomson effect. This effect is also reversible in its nature. When current passes through the single conductor having a temperature gradient, the gradient ante enti? What is gradient? Temperature gradient. Change in temperature ne temperature gradient అంటాం అన్నమాట. When current passes through the single conductor having a temperature gradient, then that heat transfer is going to be takes place. That phenomena is known as Thomson effect. Okay. Next one is Jolien effect. When the electric current flow through a conductor, there is a dissipation of electrical energy. Dissipation of electrical energy will take place, and according to Joule, Qj is equal to I square R. This is R is a resistance, I is the current. This effect is also irreversible. This effect is going to be irreversible here. And conduction effect. Last one is conduction effect. When the ends of any element are maintained at different temperatures, there is heat transfer from the hot hot end to the cold end, and is related to Q conduction, that is conduction, that is equal to U into Th minus Tc. This is the cold junction. This is the hot end temperature. The U is the overall conductance, and Co end means conduction. U is equal to Ka by Kl. One, this is the one element I am going to take here. At different temperatures, there is a heat transfer. There is a heat transfer from hot end to the cold end. This is about conduction effect. Okay, this effect is also irreversible in nature. These are the effects. But Cbec effect is please explain only Cbec effect in your exams. Okay, thermocouple only ఒక Cbec effect చెప్పండి. ఇవి మనం నాలెడ్జ్ సేక్ వీఆర్ గోన్ త్రూ అంతే. Basic thermocouple looks like this. Here there are different types of thermocouples. There are S type thermocouple, R type, T type, J type, E type, K type. There are different types of thermocouples are there. Uh, this S type, it is a combination of platinum and rhodium. This is 90% platinum is there, and rhodium is 10%. Here R type means platinum 87% and rhodium is 13%. And the T type, copper, constant and nickel. Manganese, ferrous and carbon can also be used. This is T type. And J type, ferrous and constant. And ferrous acts as a this is iron. This is Fe means iron. Acts as a positive. That means positive metal, and constant acts as a negative metal, like that here. And E type, this is a chromal and aluminum. K type, chromal, only chromal, like that. There are different types of thermocouple materials are there. Each and every thermocouple, the range is going to be differ. S type range is different, R type is different, T type is different, J type is different, like that. Different temperature ranges are there. Depends upon the temperature requirement, depends upon our temperature, maximum temperature range measurement sake, we are going to use this much this much number of different types of thermocouples are there in the market. Okay, ఇండస్ట్రీలో different types of thermocouples requirements ఉంటాయమ్మా. ఒక్కొక్క దానికి ఒక్కొక్క అప్లికేషన్ different depends upon that application as well as industry. They are going to use different types of thermocouples. It mainly depends upon the material used as well as temperature range is going to be varied. The shape of this thermocouple is like this. Let it be two dissimilar metals are connected here. This is the chromal lead, and this is the aluminum lead. This is the chromal lead. First one is chromal lead, and this is the aluminum lead. This junction, I am going to take this junction as hot junction JH. That is a measuring junction. Hot junction normally is going to be a measuring junction, and other junction is this junction. This is the reference junction. Let it be. This is the temperature controlled cold reference junction. That is JC. Let it be. We can place some ice path here, and we can take it as some reference junction. This is the free end junction. Also, we can call this as free end. and these two copper leads are connected to some meter, millivolts meter. We can measure the what is the what is the temperature in terms of voltage. In terms of voltage, I am going to measure the temperature here by using this thermocouple. There are thermocouple measuring systems are different. That is law of intermediate temperatures, law of intermediate metals, law of homogeneous circuit, like that. Different temperature measuring devices are there. That is intermediate. We can measure the intermediate temperatures. We can measure by using some intermediate metals. By using some homogeneous circuits also we can measure the temperature here. These three are by using these three laws we can measure this temperature. This is the basic view. Mm. Okay, we will see this. That is for this one it will take more time if for completing this thermocouple. That's why we will discuss this thermocouple in the next class. Don't worry. Just go through, if time permits, go through thermocouples once and come for the next session. Okay, you will see there are different types of thermocouples, and the in this thermocouples are there. In this thermocouples also series type of connection as well as shunt type of connections are also provided here. Okay, we will see that one in the next class. Mm. For this day, I am ending the session.